Alright, y'all, I have started this video 4 times. I'm hoping that this is the charm. And because I've started it 4 times, I've ruined my paper, so I've just wrote it out here. I'm supposed to use identities to find tangent and cosine, and I'm actually going to ask you to find all of them. So we're going to find tangent and cosine, sine and cosecant, cotangent and secant, based on what we know. Okay, so step 1, we're going to write out what is given. We are given cosecant of theta equals 3. Okay. Make it a fraction. We are going to apply a reciprocal identity first. So if cosecant of theta equals 3, then the sine of theta equals 1 over cosecant, so the sine of theta is 1/3. So the very first thing we're going to do is apply the reciprocal identity. So the sine of theta must be 1/3. I'm trying to get all 6. Even though the problem only wants 2, I'm trying to get all 6. So here was the one that was given, and I applied a reciprocal identity, and now I have that one. Okay. First step, figure out what's given. The one that's given with a number, and write it as a fraction if you need to, so that you can see what it flips to. Okay. Then we're going to figure out the correct quadrant, because we can't use the rest of them until we know what quadrant it's in. Okay, so cosecant is positive. Cosecant is positive here. Cosecant is positive here. You might want to use your unit circle to figure that out. Remember, it's cosine and secant, tangent and cotangent, sine and cosecant. These are the ones that are positive. So cosecant is a positive 3, so that means it's either quadrant 1 or it's quadrant 2. Secant is negative. Less than 0 means negative. Secant is negative, so it can't be quadrant 1, it must be in quadrant 2. That's going to drive everything else we find. So the very first, we're trying to find all 6. The first thing that we do is do the reciprocal, because that's the obvious one. Then we figure out what the correct quadrant is. Then we are going to apply a Pythagorean identity. Okay, and we're going to follow this process every time. Okay, so I want to apply a Pythagorean identity. So how do I know which one to apply? Well, look at the 3 of them. I can use one that has cosecant in it, or I can use one that has sine in it. This one has cosecant, so I could use it. This one has sine, so I could use it. Right now, I can't use this last one because I don't know tangent or secant. I'm going to start with this one, which is the most basic, and I'm going to write sine squared theta plus cosine squared theta equals 1, and I'm going to plug in. Sine of theta is 1/3, so I'm going to write 1/3 squared plus cosine squared equals 1. I'm going to square the 1/3. 1/3 times 1/3 is 1/9. I'm going to throw it over. I'm going to get a common denominator of 1 and 9, which is going to be 9. So I'm going to have 9 over 9 minus 1 over 9, which leaves me with 8 over 9. So cosine squared theta equals 8 over 9. But I want cosine of theta. So I take the square root of this side and I take the square root of this side. But there is a plus or a minus. So I have to figure out which one the quadrant tells me. Alright, so let's work out the math and then we'll figure out, is the correct one the positive or is the correct one the negative? Okay, so the square root of 8 is 222, so I can pull out a 2, and I have 2 on the square root of 2. The square root of 9 is 3, so now I have this. Okay, I have 2 on the square root of 2 over 3. So the question is it the positive one or is it the negative one? So I look in this quadrant. I'm solving for cosine, and I'm in quadrant 2. In quadrant 2, cosine is negative, so I apply a negative on the front of that. Okay. In that quadrant, the only things that are positive are sine and cosecant. Everything else is negative. So now we have found 3 of the 6. I applied a Pythagorean identity and I found that one. So once you've done the Pythagorean theorem, use a reciprocal again. So the reciprocal of cosine is secant, and it's 1 over that, but that just means flip it. Okay, but I can't leave a negative in the denominator or a square root in the denominator, so I do a fancy 1, and now I'm going to move the negative up top. I have 3 on the square root of 2 over the square root of 2 times the square root of 2 is 2, and 2 times 2 is 4. And now I have negative 3 on the square root of 2 over 4 equals secant. And in quadrant 2, secant is negative, so that works. Now, this next step, when I get to this point and I'm trying to find tangent, I could use a Pythagorean identity again, because now I know secant, or I could use this one. Tangent is sine over cosine. So when you get to this point, you have some options. So I'm just going to use any formula that works. Now I'm going to do the sine over cosine one because I like that one better. I don't like all the squareds. So tangent of theta equals sine of theta over cosine of theta. So I find my sine of theta, which is up at the top. It was 1/3. I find my cosine of theta, which is right here. I cannot leave a fraction divided by a fraction, so I do same, change, flip. The 3's will cancel. I'm going to move the negative up top. But there's a problem. I can't have a square root in the bottom, so I fancy 1. And now I'm going to get the negative square root of 2 over the square root of 2 times the square root of 2 is 2 times that 2 is 4. So the tangent of theta equals negative square root of 2 over 4. And we've got all of them except 1. Okay, we've got all of them except 1. So now we have to find the cotangent. Okay. And for step number 7, I'm going to say again, use any formula that works. I'm going to use the reciprocal because I know tangent. And so to get cotangent, I'm just going to flip it. So I'm going to take this fraction and I'm going to flip it upside down. Okay, right here's where I'm working. I can't leave a square root of 2 in the denominator or a negative, so I'm going to move the negative up top, and I'm going to have negative 4 on the square root of 2 over the square root of 2 times the square root of 2 is the square root of 4, which is 2. And then I can reduce because those are both outside. 2 goes into 4 2 times. So I am done now with all 6. Now your homework's only going to ask you for 2, but in practicing I want all 6. So there's cosecant and its reciprocal sine. Here's cosine and its reciprocal secant. And here's tangent and its reciprocal cotangent. Now I know that's a lot to digest, so I'm going to stop it, and I would suggest if you didn't get it to rewatch this video. You've taken your notes, rewatch it again, and now I'm going to go on and do another one, and then I'm going to let you try one on your own. Okay, so this was problem number 2, and we'll record another video.